Episode 9, Python Data Structures. Learn lists, tuples, sets, and dictionaries in simple way. Welcome back to our Python learning series. So far, we have learned how Python works, how logic flows, how conditions behave, how loops repeat tasks, how functions organize code, and how strings help us work with text. Now, it is time to learn something very important, something that is used in almost every real Python program: data structures. So now the questions we have are, what are data structures? Why do we need them? And how do they help us in real applications? If I have to explain it in simple words, data structures basically help us store data in an organized way. Instead of keeping only one value in a variable, we can store many values together at some place. We can group related data. We can manage it easily. And we can process it efficiently. In this episode, we will learn 4 core Python data structures: 1 lists, 2 tuples,
3 sets,
and 4 dictionaries. So here we will start from basics. We will understand why they exist, how they are different, and where we should use each one. Okay, so let us begin with the most commonly used data structure, which is lists. What exactly is a list? To answer this question, we can say, a list is a collection of values stored together. Instead of storing one value in one variable, we store multiple values in a single list. Think about real life. Imagine you are writing a shopping list, like milk,
bread, eggs,
fruits. You do not write each item on a separate page. You write all items together in one list or in one group. That is exactly what a Python list is. A list can store numbers. It can store text. It can store mixed data. It can even store other lists as well. Lists are very flexible. You can change them. You can add new items. You can remove items. You can update existing items. This flexibility makes lists extremely powerful. So, the next question comes in mind is why we use lists. We use lists when we want to store multiple values that belong together. For example, a list of student names, a list of marks, a list of product prices, a list of messages. Without lists, we would need many variables. Like if we want to store 5 numbers, we will need 5 variables for that. That would make the program messy, hard to manage, and difficult to scale. Lists allow us to work with data in groups. Like with the help of list, we can store those 5 numbers or any items in a single list. And that is how real programs are written. Now, let us understand how a list is created, or how we can create a list. Okay, here I am creating a list named students that stores some student names. For example, students is equals to, in square bracket we will add student names as Shubham, Tejas, Vikas, Ravi, like this. This is how we create a list in Python. Python stores these values in a sequence. Each value gets a position, just like strings. The first item is at position 0. The second item is at position 1. The third item is at position 2. So lists also support indexing, exactly like strings. In strings concept, we already learned how indexing actually works behind the scene. Now, let's learn about accessing items from a list. To access an item from a list, we use its position. This position is called an index. If we want the first item, we use index 0. If we want the second item, we use index 1. Let's access a student name called Ravi, which basically is at position 3. We access like this. Student inside square bracket 3.
Then,
Python goes to that position,
picks the value,
and gives it to us. This helps us work with individual items inside the list. Now, let's understand updating items in a list. One very important feature of lists is that they are changeable or mutable. This means we can update values inside a list. If we want to change one item, we simply replace it with a new value. Python updates the list at that position. Like if we want to change the item Shubham from a list students with a new student name Vishal, we will use its index to update the value like this. Students inside square bracket if we write its index, which is 0, and assign it a value as Vishal like this. This is useful when data changes. For example, updating marks,
or,
changing prices,
or.
correcting names. Lists allow all of this. Okay, now let us talk about adding some items to a list. Lists allow us to add new values at the end, or add a specific position. For this purpose, we have Python functions. Like append and insert, append adds new item at the end of existing list, and insert add item at the exact index or position, while all other items after that position will move one step forward. Just like this. If you write students the function insert and put the index number and the new item name, here we will add such in at the index 1. This is useful when new data arrives. For example, a new student joins. A new product is added. A new message comes in. Python provides simple ways to add items to a list without rewriting everything. Just like how we add item to a list, we can delete or remove items from a list as well. Sometimes, we also need to remove data. A student leaves. A product is discontinued. An item is deleted. Lists allow us to remove values easily. We can remove by value or remove by position. If we want to remove item by position, we can write index inside the pop function like this. Students.pop, and inside that the index of the item. If we want to remove by value, then we simply use remove function like this. Students.remove, inside the function we write item which we want to remove. This makes lists dynamic and practical. Now comes the main point, that is looping through a list. One of the most powerful things we can do with lists is looping. We can go through each item one by one. We can print them. We can check conditions. We can apply logic. This is where lists connect beautifully with loops. We can use for loop, advanced for loop, and all. For this, let's write a loop to loop through the student list and print each item. And this is how most real programs process data. Now, let us move to the next data structure, which is tuples. So now the question is, what exactly is a tuple? To explain this simply, we can say, a tuple is also a collection of values stored together. Just like a list. At first look, a tuple and a list may look the same. Both can store multiple values. Both can store numbers. Both can store text. Both can store mixed data. But there is one very important difference. A tuple is not changeable. Once a tuple is created, we cannot modify it. We cannot add new items. We cannot remove existing items. And we cannot update any value inside it. This means tuples are immutable. Let's understand the difference between list and tuple. A list is declared using square brackets. That means a list is written inside square brackets, whereas a tuple is declared using parentheses. That means a tuple is written inside round brackets. So visually also, there is a difference. And functionally also, there is a difference. Lists are mutable, which means they're changeable. And tuples are immutable, which means they're not changeable. This is the most important thing you must remember. Why we use tuples. So now the next question comes in mind. Why do we use tuples when we already have lists? We use tuples when data should not change, when data is fixed, when data should remain constant throughout the program. Let us understand this with a real-life example. Think about the days in a week. We have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday,
and Sunday.
These days will never change. You will not add an extra day. You will not remove a day. And you will not rename a day. So for such fixed data, tuple is the perfect choice. Creating a tuple. Now, let us understand how a tuple is created. A tuple is created using parentheses. Here, I am creating a tuple named days. And inside the parenthesis, I am storing the days of the week. Like this, separating value with comma. This is how we create a tuple in Python. Python stores tuple values in a sequence. Just like lists. Just like strings. Accessing items from a tuple. Tuples also support indexing. The first item is at position 0. The second item is at position 1. The third item is at position 2. So, if we want to access a specific value, like here we will access Saturday, Python goes to that index, which is 5, picks the value, which is Saturday, and gives it to us. Accessing items in a tuple works exactly the same way as lists. Here, important point to remember is, in a list, we can update values. But in a tuple, we cannot update values. If we try to change any item inside a tuple, Python will throw an error. This is Python's way of protecting fixed data, when to use tuple instead of list. So, remember this simple rule. If your data can change, use a list. If your data should not change, use a tuple. This one rule will help you choose the correct data structure while writing real-world Python programs. Now, let us learn the next data structure, which is sets. What exactly is a set? To explain sets in Python, we can say, a set is a collection of values stored together.
Just like a list. Just like a tuple.
But again, sets have their own special behavior. A set stores unique values only. This means no duplicate values are allowed in set. If you try to add the same value again and again, Python will keep only one copy of it. Let us understand this with a real-life example. Imagine you are creating a list of unique student IDs. Each student can have only one ID. No two students should have the same ID. If someone tries to add the same ID again, it should not be accepted. This is where sets are very useful. Okay, so now we will discuss some important points about sets. A set does not allow duplicate values. A set does not maintain order. This means items are not stored in a fixed sequence. So basically, you cannot rely on positions like index 0 or index 1, because sets do not support indexing. This is a very important difference. Let's see a difference between list, tuple, and set. About duplicate values. A list allows duplicate values. A tuple allows duplicate values. A set does not allow duplicate values. Then about order. A list is ordered. A tuple is ordered. A set is unordered. And when we consider about modification or change in values, a list is changeable. A tuple is not changeable. A set is changeable, but without duplicates. Okay, that's good now. Let's see how to create a set. A set is created using curly brackets. Here, I am creating a set named student ID. And inside the curly brackets, I am storing some student IDs like this. If I accidentally repeat any ID, Python will automatically remove the duplicate. This happens silently, without throwing any error. This is Python's way of ensuring uniqueness. Adding items to a set. Now, let us talk about adding items to a set. We can add new values to a set. But remember, if the value already exists, Python will ignore it. This is useful when you want to maintain a clean collection of unique data. Let's see how to remove items from a set. This is useful when data is no longer needed, or when a value becomes invalid. Since sets are unordered, we remove items by value. We use the method remove for removing element from set like this. And we cannot do anything with index because set does not support indexing. Okay, now the big question is, when should we use a set? We use sets when we want unique data, when order does not matter, and when we want fast checking. For example, we can use set for removing duplicate values from a list, storing unique email IDs, tracking unique users, handling permissions. Sets are very powerful in such cases and works perfectly. Now, let us learn the last data structure of this lecture, which is dictionaries. What exactly is a dictionary? So now the question is, what is a dictionary? To explain dictionaries in Python, we can say that a dictionary is a collection of data stored in the form of key and value pairs. A dictionary basically consists of two parts, a key and the value. At this point of time, just keep in mind the key is always unique while value can be duplicate. This is different from lists, tuples, and sets. In a dictionary, each value is connected to a key, and using that key, we can access the value. Let's understand this with a real-life example. Imagine a real dictionary. You have words, and for every word, there is a meaning. So in dictionary data structure, the word is the key, and the meaning of the word is the value. This same concept is used in Python dictionaries. So now the next question comes in mind is, why do we use dictionaries? Basically, we use dictionaries when we want to store data in a meaningful way. When each value has a name or key, or when data needs to be mapped. For example, storing these type of data like student roll number with student name, product ID with product price, username with password, employee ID with employee details. This makes data easy to understand and easy to access. Let's explore some important properties of dictionaries. A dictionary stores data as key and value pairs. As we learned, keys are always unique, and values can be duplicate. A dictionary does not store data using index positions, so we do not access values using index 0 or index 1. Instead, we access values using keys. Difference between list, tuple, set, and dictionary. Now, let us quickly understand the difference. A list, tuple, and set stores values only. A dictionary stores key and value pairs. A list and tuple are ordered. A set is unordered. And a dictionary stores data based on keys. A list is changeable. A tuple is not changeable. A set is changeable but without duplicates. A dictionary is changeable using keys. Now, let's see dictionary in action. Okay, now let us see how to create a dictionary. A dictionary is created using curly brackets, just like a set. But the difference is, inside a dictionary, we write key and value pairs. For example, here. I am creating a dictionary named Student Details. And inside it, I am storing student roll number with student name. Each key is connected to its value. This is how we create a dictionary in Python. Now, let us see how to access values from a dictionary. To access a value, we do not use index. We use the key. So, if we want a student name, we use the roll number key. Python goes to that key, finds the value, and gives it to us. This makes dictionaries very powerful. Next, let us understand updating values. Dictionaries are changeable, so we can update values easily. If we want to change a value, we use the key and assign a new value to it like this. Python updates the value for that key. This is useful when data changes. For example, updating student marks, changing product prices, updating user details. Okay, now let's add new items to a dictionary. We can also add new data to a dictionary. If we add a new key with a value, Python simply adds it to the dictionary. This is useful when new data arrives. A new student joins. A new product is added. A new user registers. Now, let us see how to remove data. We can remove data from a dictionary using keys. This is important when a student leaves,
or
if a product is removed,
or
if a user account is deleted. We remove the key by using the pop function or by using del keyword, and Python removes the value connected to it. Now the final question. When should we use dictionaries? We use dictionaries when data has a clear meaning, when values are connected to names, when fast access is required, and when data needs to be organized clearly.
For example,
student records, user profiles, configuration settings, product catalogs. Dictionaries are one of the most powerful data structures in Python, and they are used heavily in real-world applications.